Good evening.
Good evening, sir. Yeah, thank you so much, sir. Good evening, everyone. I hope I'm audible.
Yes, ma'am.
Yes, ma'am. So, shall I start? Yes, ma'am. Okay, so I think I shared two sheets today. Hope you people have received on WhatsApp. Have you seen sheets are shared?
Yes, ma'am.
Yes, ma'am.
Fine. So I think we ended yesterday on independent sample status, right? Just a minute, I'm just opening my slide and then we'll start. Okay. Okay. Please confirm whether screen is visible or not.
Yes,
Yes,
ma'am.
Fine. Thank you. So, friends, we are starting with the next topic, which is paired sample status, right? So, yesterday, when I talked about parametric test, I think we've understood the concept of parametric test. I said there are various different tests that are available in this particular category. One of them is the t-test, right? So in t-test there are varieties. So we have understood the concept that t-test is generally used when we are interested to find the significant mean difference, right? So in that case we are using the t-test. Now, uh, one sample t-test. In case of one sample t-test, we are comparing the sample mean from the hypothesized mean or probably from the population mean. In the independent samples, we are comparing with two different populations, right? Or we can say we are comparing two different samples, or we want to find the mean in the two different samples in case of independent sample status, right? In the category, the last test in the t-test category is the paired sample status, right? So paired sample status is what? It is again a test which can help you to find the significant mean difference. But in case of paired sample t-test, you need to have, means it is very important to understand that when we talk about paired sample t-test, you need to have only one variable and you need to have one sample, right? And you are repeating or you are calculating measuring your variable twice for a same sample, right? So that way it is known as paired sample status. So in case of paired sample status, your sample will be paired. So possibility of pairing is only when you are repeating the same sample, right? So that means suppose a particular company wants to see whether there is any differences coming in the performance of employees or not, right? So for the purpose, company has taken their performance initially and then company has provided them some training and all, and then after some period of time again their performance will be recorded, will be recorded by the company. So in that case we can see for the same group of people we are taking data twice, right, on a particular time gap. So that way it is a case of paired sample status when there is a pairing in a sample. So that way it is known as paired sample status. I hope concept is clear.
Yes, ma'am.
Right. Now, further talking about the assumptions of paired sample status. So here the assumption says the dependent variable should be continuous. As I said, there will be only one variable and that variable will be treated as dependent. Or maybe you can say this is your numeric variable, right? So this variable should be continuous or numeric. or should be measured on interval or on ratio scale. This is the first assumption. Second one is the differences between the scores of variables are normally distributed. You need to take the difference in these variable scores, and you need to see that whether that difference is normally distributed or not. The third one is the differences between the scores of variables do not means there should not be present any significant outliers in that difference. So these are the three important assumptions when we are talking about paired sample status, right? So hypothesis form of the paired sample status can be the mean difference between variable scores is equal to 0 in the total population, and the mean difference between the variable scores is different from 0 in the total population, right? So that way you want to see whether the two times when we are measuring the same variable, the difference is coming 0 or there the difference is not 0. This is what you need to check in case of paired samples t-test, right? So generally how to do the reporting of t-test? So you need to see the t-value, you need to see the degrees of freedom, you need to report the p-value, the mean difference, and sometimes confidence interval of difference also we are reporting, right? So this is the conceptual aspect of paired samples t-test. I hope it is simple to understand. Yes. May I proceed?
Yes, ma'am.
Fine. So you need to open a sheet named as math test. I think you please check the WhatsApp. On WhatsApp, I have provided you the sheet named as math test. Open that sheet. Once you are ready with the sheet, please tell me so that we can proceed. Shall I start? Please say something, friends. Are you all
Yes,
ready?
Yes, ma'am. Ready.
Fine. So here you can see in this data sheet I have provided you 4 column. You can see we are having grade 1, grade 2, and one more combination is before and after. So here I am firstly talking about this grade 1 and grade 2. So suppose being a teacher, suppose you are conducting a test of your students, right? Before teaching them, suppose we are conducting a test and we want to see their knowledge level, right? After teaching the same particular subject, you are again conducting a test and you are collecting their score. So that way we are having two grades, grade 1 and grade 2. That means for the same student, we are having two different scores, right? Fine.
yes, ma'am.
So that way you need to see, firstly, we are having a numeric variable available with us, that is the grade, right? Now we need to see whether there is significant difference in the grades before teaching and after teaching or not, right? So that way, according to the assumption, first one was that we need to check whether the variable is numeric, that is continuous or not. So I think it is quite visible. It is a numeric variable with us. Now what you need to do, you need to see, take the difference first, right? So for the purpose, you need to go to the transform menu or tab. So those who are performing, please go to the transform tab, click on compute variable. Once you are able to locate it, please tell me so that I can tell you the further process. Go to the transform and select compute variable. It is done.
Yes, ma'am.
Yes, ma'am.
Give the name to your variable. Suppose I want to give the name as difference because I want to take a difference of grades. So I have written here name as target variable is the difference. So this difference will be equal to Grade 1 you can select and shift it into the numeric expression box. Using a calculator, put a minus sign and then select grade 2 and shift. Done, I hope.
Yes, ma'am.
Click on OK. Now come to your data sheet and you can find at the end one more column is added as a difference, right?
Yes, ma'am.
Now for this difference, you need to check whether the difference is normally distributed or not. How I can check the normality? Anyone? Anyone? What I need to do for checking the normality? Yes, anyone?
Ma'am, you have to go to first analyze option and then descriptive statistics and then explore.
Very good, thank you. Now,
Uh, Now you have to select these options, grade 1, grade 2, all in the dependent list.
no, we will take only the difference because for the difference you need to check the normality.
Okay.
Then I shifted after this
Plots.
yeah, statistics and outliers, right? Then plots and then
Histogram.
histogram, right? And normality plots with tests. Good. Continue and then okay. I hope output is visible, right?
Yes, ma'am.
Now you can check. We are having total 359 observations, right? No missing value. Total observations are 359. Descriptive you can find here for the mean or the mean difference is minus 1.17. 95% confidence interval for mean is minus 1.23 as a lower bound and upper bound is minus 1.12, right? 5% trimmed mean minus 1.18, median minus 1.9, and likewise you can read. Come down and see the skewness and the kurtosis value. So the kurtosis is minus 0.63 and skewness is 0.243, right? So you can check this. Further, you can go down and you can refer the table named as test of normality. There you can see the Shapirovics test is this, right? So you can find the significant values coming as 0.108, which is greater than 0.05. If it is greater than 0.05, what interpretation we will draw? Yes.
Accepted. Accepted.
We will accept the null hypothesis. So what we will conclude? Yes. Anyone? What we will conclude?
That there is no significant difference. No,
I think-
there are no,
Mhm.
there are no outliers. I mean, it's a
It is a test of normality.
normality. Yes.
Yes.
There are no outliers. Yeah. I mean, It means that the amount of outliers are acceptable. That's what it means. Ma'am, you're muted. We can't hear you.
Okay. Am I audible now?
Yes, ma'am.
Yes, ma'am.
Yeah. So I think I said when we were talking about previously about this table, I said Shapirovich's test null hypothesis is variable is normally distributed, right? So we are accepting the null hypothesis. So we will say variable that is difference of the grade is normally distributed, right? Right? I hope it is fine.
Yes, ma'am.
Friends, say yes or no.
Yes, ma'am.
Fine. Go down. Then you can see this is the histogram, right? So looking at the histogram, I think I told you how to put a bell-shaped curve. If you wish to put, you can double click on this and then you can use this normal or this row distribution curve. And you can close this window also. So this is indicating whether the distribution of this normal or not. So almost you can find most of the bars are coming inside the bell-shaped curve. So somewhere we can say that the difference of grade is normally distributed. Looking at the QQ plot, some deviation you can find at the lower and the upper side. Remaining data points are following the fitted line. Outlier you can see here. If you will talk about the box plot, you can check at the upper side some of the circles you can find. 3 circles are coming. That means 3 outliers are there, but these are circles and not the asterisk. That means these are insignificant outliers. Fine, everyone? Friends, done?
Yes,
Okay.
ma'am.
Now, I think we have checked assumptions. We'll go to perform paired sample status. So go to the analyze, select compare means, and then paired sample status. Select this. Done?
Yes, ma'am.
Now shift grade 1 into the variable 1 box using the arrow key, grade 2 into the variable 2. Done? Done,
Yes, ma'am.
everyone? Now nothing we need to do. Click on OK to get the output. I hope my output window is visible. Done?
Yes, Yes, ma'am. ma'am.
Now you can check. First table is talking about the paired sample statistics. There you can see the mean in case of grade 1 means once you before teaching, when we have taken the exam, so the grade is coming, average grade is coming in 6.01. After teaching, the grade is coming as 7.19. So that is you can find in both the conduct, same group of people will be there. So the total sample size you can find 359. Standard deviation in the difference of grade is 0.48 and 0.188. Standard error of mean is 0.025 and 0.0099, right? Then the paired samples correlation table you can find.
Mm.
So then paired samples correlation table you can see, you can find for total 359 respondents, the correlation value is coming as 0.007. That means in the grade 1 and grade 2 correlation is very weak. It is a very small correlation value, right? And this is also not significant, right? Now main table is the paired sample status table. There you need to see the difference in the grade is coming as minus 1.17. This is the main difference. And this is the standard deviation in the grade. Standard error of mean is 0.02727. 95% confidence interval of mean is minus 1.2 and minus 1.12, lower and upper bound. Main value is the t value, which is coming as minus 43.150. For the degrees of freedom, 358, right? And the significant value or the p value is 0.00, which is less than 0.05. So anyone who can help me to conclude what I need to say here? Yes. This is less than 0.05. Means? Yes.
Null hypothesis
Accept-
will be rejected.
Accepted.
Null hypothesis rejected. Very correct. If we are rejecting the null hypothesis, what conclusion we will draw?
There is significant difference
There is a
between the
significant difference.
samples. Between the
There is a
samples.
significant difference in the mean grade. You know? There is a significant difference in the mean grade of students, right? Before teaching and after teaching. Yes or no?
Yes, ma'am.
Yes. If the difference is existing, and if I want to say that there is an increase in the knowledge level of the student, so can I say if there is an increase? Yes. May I say this? Yeah. Anyone? Yes. Okay. So I think when the difference is coming and we are finding the difference is significant, so we can see the mean values. Before teaching, the grade was mean grade was 6.01. After teaching, the grade was 7.19. That means grade has improved. That means there is a increase in the knowledge level. Yes or no?
Yes, ma'am.
Or we can say that the teaching is effective because grade has improved or increased in the second conduct, right?
Yes.
Right. So this way, this is paired sample status. I hope there is clarity when I'm talking about paired sample status. Yes.
Yes, ma'am. Yes, ma'am.
Fine. So I'll move to the one-way ANOVA now. I hope slides are visible.
Yes, ma'am.
I think I need to tell you one more thing. I think in the same sheet which we were discussing for the paired sample status, one more means two more columns are there before and after. So using that, you can do, if you want to do a practice of paired sample status by your own, you can use that data. That data is related to I think I need to check whether the height, weight, whatever is given. So that is a kind of any kind of program is offered to the participants where they are, or respondents where the company is claiming if you will use this, it will help you to reduce the weight. If it is a case of weight, it will help you to reduce the weight, or if it is a case of height, so it will help you to improve or increase the height, right? So that way you can use that particular two columns data for performing the paired sample status. Fine. Now coming, yes,
Ma'am, I have a doubt.
yes.
Ma'am, what if we have to use a Mann-Whitney U-test, which is sort of
The
we sometimes.
non-parametric test
Yes,
category
ma'am.
is available.
Yes, ma'am. But
So
sometimes when
using,
we have, yes, ma'am.
yes,
When we have our data, which is sometimes not normally distributed, then we'll have to go for this for the Mann-Whitney U-test. So in that case, how do we modify like what you have?
and analyze non-parametric test category
Yes,
is
ma'am.
available. There you will go and you can find there is K means, I think something is given. From there, you can locate that, and you need to shift your variables, and it will generate the output. So I think one way ANOVA I'll discuss, and then if possible, time permits, I'll tell you. Right?
Okay, ma'am. Yes, ma'am.
Yeah. Okay. Now you can see when I talk about the ANOVA stands for analysis of variance, right? So generally we are interested to see the variance in the mean. In that case, we are using one-way ANOVA. This is the test which is given by Sir Ronald Fisher. He was the British statistician. So after his name, generally, and you can see when you are getting the output of ANOVA, and ANOVA is represented by capital letter F, right? So it is coming from this Fisher only, right? So this is again one of the statistical tests which can help you to find the significant mean difference, right? So whenever you are interested to find the significant mean difference, either you can use the t-test or you can use the ANOVA. So question comes, when to use which? Answer is very simple. When you want to compare two groups, you will use t-test. When you want to compare more than two groups, you will use one-way ANOVA, right? So meaning is that whenever you are having more than two groups available in your categorical variable, and you want to compare all mean of your dependent variable in all the groups of categorical variable simultaneously, in that case you are using one-way ANOVA, right? For example, if your independent variable is a variable of related to the teaching methods or teaching techniques, so might be possible you are having techniques like audio technique, video technique, discussion, etc. So in that case, if you want to see from which technique or which technique is helping to improve the marks of students or all, then in that case you can use one-way ANOVA there, right? Those who have performed regression test using any of the software, they have also noticed in the output of the regression, we are also getting the ANOVA table. So the role of ANOVA table is what? It can help you to ascertain that whether there is a linearity in the variables or not in case of regression, right? So that is why we can say that ANOVA is a precursor in case of general linear modeling, that is a regression case, right? Now, when we talk about one-way ANOVA is commonly used as a test for generally finding the significant difference among the means of two or more groups, or between or maybe among the means of two or more interventions, or maybe to find the means of two or more change scores, right? So in the case of these different situations, we can apply one-way ANOVA. Now, the variable requirement in case of one-way ANOVA. In case of one-way ANOVA, we need to have two variables, the independent and the dependent. Means it is very similar like independent sample t-test. If you can recall, yesterday itself I discussed independent sample t-test. There I said we need to have two variables when we want to perform independent sample t-test. So which two variables we need to have? That is dependent, independent, or you can say numeric and categorical. So same variable requirement will also be there in case of one-way ANOVA. In case of one-way ANOVA, you need to have one dependent variable which will be numeric and one independent variable which will be the categorical variable with more than two categories, right? So this way you need to see this will be the variable requirement. I hope till here I am clear to everyone. No doubt so far.
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Then, yeah, as I think I have just said, dependent variable will be continuous, independent variable should be categorical with at least three labels. For example, here you can see we are having the example which I just discussed. Marks is the dependent variable and the teaching techniques are independent variable with the three different labels or groups. Discussion, audio, and video means the students which are studying using the discussion method, students which are studying using the audio method and video method. So these we need to collect their scores and we need to find whether any difference is coming in the scores or marks or not. So this will be the case of one-way ANOVA. I hope it is clear.
Yes, ma'am.
Fine. Now it's turn of assumptions. Number one, that it is assumption of independence, means it is like we need to be careful that from one person you need to collect data only once. That way you can maintain your assumption number one. Next is the assumption of normality. So your dependent variable should be normally distributed. Next is assumption of homogeneity or variance. So again you need to check whether the variable is having the same variance in all the categorical variable groups or not. So this is what you need to check. And you need to see lastly that there should be no significant outliers available in your dependent variable. So these are the some of the assumptions of one-way ANOVA. I hope it is clear. No doubt, any doubt, please ask.
Clear,
Yes,
ma'am.
clear. Moving to the next, if assumptions of ANOVA is not meeting, in that case, the suggestive test in the non-parametric test category is go for Kruskal-Wallis test. Done, everyone?
Yes, ma'am.
Fine. Now, I think this is already I have shown you when the data is showing such kind of distribution and you are repeating through the histogram, somewhere you can say that your data is approximately normally distributed. Then relevance test already we talked in case of the independent sample status, where we have seen that the variance of the dependent variable should be same in all the groups of the categorical variable, right? So that way your last or second last assumption is also you can check using the SPSS. Is it clear till now?
Yes, ma'am.
Yes, ma'am.
Fine. Today I think I'm feeling little uneasy, so my eyes are not opening properly, right? So please don't mind. Next one
Okay,
is
ma'am.
next one is we need to formulate the hypothesis of one-way ANOVA. Symbolically, if we are writing the hypothesis of one-way ANOVA, so we are writing all the mu's, means if we are having multiple groups, for all the groups means are equal. This is the null hypothesis. Alternative hypothesis says at least one of the mu, one of the mean is not same, right? Which is different. So that is the null hypothesis and alternative hypothesis in case of one-way ANOVA, right? Symbolically, this is a way of writing the null hypothesis. Then if I talk about if we are performing ANOVA using the softwares, right? Even then we are getting, this is the final table which we are getting even in SPSS also and in Excel or in other softwares also, right? So here the if you can see these are, this is known as source of variation, means through what sources the deviation is coming or the variation is coming in the mean. So sources can be the treatment and then and the second source is known as error, right? So next is next column is known as sum of squares. After that we will be having the degrees of freedom, then mean sum of square, and the calculated value, that is that is the statistic value of the f, and the critical value of the f we can find, and then we can compare and make decision. So this way, this is the way what I can say, this is the format of the table of the one-way ANOVA. Now next is how to perform one-way ANOVA. So I think you can see these are the various options which you need to do or perform one or to get the output of one-way ANOVA in SPSS, right? So I think I'll tell you all these one by one once we will go to the SPSS. So I think friends, this is about the conceptual aspect of ANOVA. Till here I think I'm clear. Any doubt so far?
No doubt, ma'am.
Fine. May I proceed to the next sheet?
Yes.
Fine. So friends, you need to open the second file which I provided to you. I think it is for the employees data, right?
Yes, ma'am.
Fine. Now we will check. We are having multiple variables available in this sheet. You can check in the data view. You are having ID, gender, birth date, education, job, category, salary, etc. Multiple variables are available with us, right? So firstly, you need to decide upon on which variable we are going to apply one ANOVA. So you can check gender. We are having, right? In gender, you can find we are having two groups, male and female group. And in the job category, we are having the three groups, 1, 2, and 3. So that means for ANOVA, it is better in comparison to gender, because gender is a variable which is having only two groups or two categories, right? So I will take here the job category and the salary. So we need to compare the salary of the employees on the basis of their job category. It is clear till now?
Yes, ma'am.
Right.
Yes,
Now,
ma'am.
firstly, we will check the assumptions. So first assumption is generally we can say it is about the variables. Your DV or numeric variable or your dependent variable should be continuous or numeric. So that way you can say salary is the numeric variable, right? Independent variable or categorical variable should be, again, if you talk about it, should be a categorical variable with the three or more groups, right? So you can check job category is a kind of categorical variable. There we are having total three categories, right? So probably name will also be there. You can come to the variable view and you can check for the job category. There you can click and you can see one for the clerical, two is for the custodial, and three is for the manager. Is it okay?
Yes, ma'am.
Now you need to go and check the assumptions first. So we will go to the analyze, descriptive statistics, and then we will use the explore. We will shift current salary, that is salary, into the dependent list box, and the job category, employment category into the factor list box. Done, everyone?
Yes, ma'am.
Sorry, anyone something is asking?
And one more time, can you please tell, ma'am?
Okay. Go to the analyze, descriptive statistics, and explore. Done?
Yes, ma'am. Yes, I have done, ma'am.
Yes. Now shift the current salary into the dependent list box and job category, that is employment category, into the factor list box. Done?
Yes, ma'am.
Now click on the first button is the statistics. So if we want to look at outliers, we can select this, click on continue, and in the plots, as we have selected previously, histogram and the normality plots with tests, and then continue. I hope it is okay. May I press OK?
Yes, ma'am.
Now click on OK. Fine. Now we will see the output. In the case processing summary, you can see that we are having total 363 clerical staff, 27 custodial, and 84 managers. No missing value. So the valid or the total data is same as valid. I think it is so far very easier every one of you to understand, right? May I proceed now?
Yes,
Yes,
ma'am.
ma'am.
Now come to the, yes. Anything you want to ask me? Yes. Shall I proceed?
Yes, ma'am.
Fine.
Ma'am.
Yeah. So now you can see when I talk about descriptives. So for salary, you can find 3 times we are getting descriptives. One for clerical staff, second for custodial, and last for the manager, right? So when I talk about this clerical, you can check here. The mean current salary for the clerical staff is $27,838, right? This is the 95% confidence interval of mean, and 5% mean is coming as 27,290 $0.50. Then median is 26,550. Then variance is a very big figure, something in crores or something. Then standardization is 7,567. Minimum of the current salary is 80,000. Sorry, minimum is 15,750 and maximum is 80,000 for the clerical staff, right? Then interquartile range is coming as 8,400. Range is coming as 64,250, right? Then skewness in corpuses, if you will see, these are little bigger figure, right? That means there is some problem with the normality of clerical salary of clerical staff. Next is the custodial. In the custodial also you can read all the values. Mainly you need to check skewness in corpuses, which is coming as we can say skewness is almost 0. It's minus 0.3 something. It is almost 0, right? Next one is the for the last category, which is the custodial. No, for custodial, I think I read, no, it is minus 0.368 and 3.652. That means again not very good measures we are getting for skewness and kurtosis. Still we'll go for the last one, which is for the manager. There you can find a mean salary you can read. Main thing is that you need to see the skewness value for managerial staff is 1.181. For the kurtosis is 2.107. So this way it is talking about the normality of the salary in case of all the three different groups. So everywhere you can find there is a problem with the normality, we will see. Then moving to the next, it is told, showing you the extreme values in your data concerning to all the three different categories for the salary. Then next is the test of normality. Here you need to report the Shapiro-Wilks test. In this case, you can find the significant value is less than 0.05. So what is the meaning of this? Anyone? If p value is less than 0.05, what interpretation we will draw?
Reject.
Yes, we will reject the null hypothesis. Fine. So what we will conclude? Anyone?
The job category and the salary are dependent on each other.
Sorry, again?
The job category and the salary are dependent on each other.
No.
No, ma'am, here it is not normally distributed.
Yes, very correct.
The normality is not established.
Yes.
Yeah.
Normality is not established. It is not met by your data for all the three categories for the salary. Right? Salary is not normally distributed here. This is what we can infer from the table. Similarly, if you will look at the histogram for the clerical, you can find it is positively skewed data. Similarly, for the manager, no, it is for the custodial category. So as number of observations are very less, it is only 27 employees, right? So that is why this histogram is not coming properly here. Next is for the managers. Sorry, managers also you can find this is indicating that salary is not normally distributed, right? QQ plot for each category you can check here. For the clerical, again you can find there is a problem with normality as there is a very large deviation from the fitted line. Then for the job category custodial, you can check that there are points not exactly following the fitted line nearby to it, but still some deviation we can observe. And lastly, for the managerial staff, you can check that again you can find there is some curve type curve is coming. That means your data is negatively skewed data in case of the last category, which is manager. Fine, everyone? Yes?
Yes, ma'am. Yes, ma'am.
Done. And then we'll go down and we'll check the assumption of outlier also. You can find here in all the three categories. If you will look at the box plot, at the upper side in all three cases, if you can see, there are certain outliers are available. so that you can find these asterisks. I think visible clearly. These asterisks are indication that these are the significant outliers. So you can go in the data sheet and you can directly delete them if you wish, right? But I think this is a demo class I think I'm taking, so I'll keep them and we'll go ahead and we'll perform the ANOVA. So this is the assumption checking so far. Only one assumption is left, which is the homogeneity of variances that we will check in the output of ANOVA only. Fine, everyone?
Yes, ma'am.
Fine.
Yes, ma'am.
Fine. So now for performing the ANOVA, we need to go to the analyze, compare means and one way. I hope visible. May I select this? Fine. So click on this. Everyone got the same window?
Yes, ma'am.
Fine. So you need to shift your current salary into the dependent list box and the job category into the factor box. Done?
Yes, ma'am.
Then after this, go to the post hoc is there is a problem with the ANOVA. What is the problem? ANOVA can only tell you whether, well, means it is simultaneously telling you whether a significant difference is existing or not, right? It is not clearly telling you in which pair of the mean the difference is significant. So that is a problem with the output of ANOVA. So for the purpose here, we are having the post hoc test also for multiple comparisons, right? But firstly, you need to understand this thing, whether the difference is existing or not. If difference is existing, only then there is a use of post hoc test. If difference is not significant, you will not use the post hoc test. Clear, everyone? So we will come to this
Yes, ma'am.
later on. Then you can click on the options and you need to select under the statistics, you need to select descriptive and homogeneity of variance test. If homogeneity of variance test is not fulfilled by data, you can report Welch also. If you wish, you can click on Welch test also. Then,
Yes, ma'am.
now click on continue and then OK. I hope everyone has got the output.
Yes,
Those who are
ma'am.
performing got the output.
Yes, ma'am.
Now you can see the first table is a descriptive statistics table. There you can find these are the number of observations for each of the employee, right? That means we are having total 363 clerical, 27 custodial and 84 managerial staff, right? Then the mean salary for all the three category employees are listed in the next column. Standard deviation in the salary is listed in the next column. Standard error of mean is listed in the next column. And then 95% confidence interval for mean is listed, right? The minimum and the maximum salary of all the three categories are listed here. So this way, this is the descriptive statistics table. Coming down, talking about test of homogeneity or variances, you can check here on the basis of mean we are generally reporting. You can check the significant value is 0.000. So anyone who can help me to interpret if it is 0.000, what I need to do, what I can say. Yes, anyone?
Ma'am, it rejects the null hypothesis.
We are
Yeah.
rejecting the null hypothesis, correct? Yes.
So
Yeah.
it
There
doesn't
is a
show number.
difference.
So it is indicating their variance is not equal because null hypothesis of this Levens test is variance is equal. This is null hypothesis, but our data is not supporting the null hypothesis, right? We are going with the alternative hypothesis. We will say variance is not equal. Is it okay?
Yes.
Now coming to the ANOVA table. So as variance is not equal, I told you rather than reporting the ANOVA results, you can also report the Wells test, right? Is it okay? Which is coming in the last table. So if you will see the ANOVA table, in ANOVA table, significant value is 0.000. That means we are rejecting the null hypothesis. And even in the Wells test also, you can find that the significant value is 0.000. That means we can reject the null hypothesis, right? Yes or no?
Yes, ma'am.
So if we are rejecting the null hypothesis, what we will conclude?
We will conclude that the job category is and the salary is job category salary is dependent on the job category.
Yes. We can say there is no significant difference in the mean salary of all the three categories employees, right? This is the null hypothesis, but we are rejecting it, so we will say there is a significant difference in the mean salaries of all the three categories employees. Yes?
Yeah.
Right. So when the significant difference is existing, ANOVA is lacking to comment in which pair the difference is significant, where in the pair of the manager and custodial, or manager or clerical, or custodial or clerical, whether in which, means in which category the difference is significant, it is not commented or it is not communicated by the ANOVA. This is the lacking of ANOVA. For the purpose, we need to apply the post hoc test, right? So as our ANOVA or the Wells test null hypothesis is rejected, that means we can go for the post hoc test. Fine, everyone? Yes or no?
Yes, ma'am.
Fine. So when the difference is coming, we need to again apply. So go again, tap on the analyze, click on compare means and select one way ANOVA. Done. Everything is already set. Now you need to only click on the post hoc. Done. Everyone, have you located this?
Yes, ma'am.
Now you, in this particular dialog box, you can find there are two sections. First is equal variances assumed. Second is equal variances not assumed, right? That means in the post hoc test category, there are two families. So one family is having the test which is based on the variance is equal, right? And second category is variance is not equal. Fine, everyone. In our case, if we will see the test of homogeneity of variances, which is the Levens test, anyone can tell me what interpretation we have drawn from that test? Anyone? I think we said variance is not equal, right? Yes or no?
Yes, ma'am.
Do I need to show you? You can see here, in case of this homogeneity of variances test, I think we have concluded this thing, variance is not equal. Yes or no? Yes?
Yes, ma'am.
So that is why I'll go in the post hoc test and then I will use or I will apply the test which is available under equal variances not assumed. So one of the tests you need to select here. Fine, everyone. This is not applicable in our case. Okay.
Yes, ma'am.
So
Yes, ma'am.
here, usually most used tests are the Dunnett test, and sometimes people are using Games Howell also. So if you wish, you can select both the check boxes, click on continue, and then OK. So every remaining results are repeated. So we are not interpreting, we are directly coming to the multiple comparisons post hoc test section. There you can find, if you are referring Dunnett 3, T3, you can see there will be 3 pairs, as we are having 3 groups. So pair will be clerical and custodial, clerical and manager, and lastly, it will be the manager and the custodial. These 3 combinations you need to match, right? So you can check in the first section, clerical and custodial. In the first row, if I am moving, significant value is 0.000, which is less than 0.05. So I can say this thing, there is a significant difference in the mean salaries of clerical and custodial staff. Similarly, when I'm comparing clerical and the manager, so I'll go in the second row, significant value is 0.000, which is again less than 0.05. So I'll say there is a significant difference in the mean salary of manager and the clerical staff, right? And last combination is custodial and manager. So in this combination, you can find fourth row, which is 0.000, which is less than 0.05. So I'll comment that there is a significant and custodial staff. Is it okay?
Yes, ma'am.
Similarly, you can compare your results from the game Sowell also. In case of game Sowells also, you can find all the significant values which are listed are less than 0.05. So that means even I'll talk about Dunnett theory, or if I'll talk about games and Howell test, in both the cases you can find same results we are drawing. That means in all the cases, in all the pairs we have found the significant difference in the mean salary is existing. Is it clear?
Yes, ma'am.
Right. Now, I'll again go to the one way over. So I'll select this. Now we have seen the use of these two. I'll show you the use of contrast also. Click on the contrast button. Done. Open, everyone.
Yes, ma'am.
Now you can see here, if I come to the contrast 1 of 1, right? In this section, you can find there is a box named as coefficient, right? It is asking you to provide coefficient. So what is the meaning of this? So using this particular dialog box, you can also apply the t-test, right? How? So you need to be firstly deciding this thing in which pair you want to check the significant mean difference in the salary. As we are having total 3 categories, that is clerical, manager, and the custodial. So anyone who can tell me in which 2 categories we want to find the mean difference or want to check the mean difference? Which 2 categories I'll need to select? Anyone? Anyone?
Clerical and manager.
Clerical and manager. Fine. So I'll need to check this time. I'll come to my data and I'll check in the variable view. Job category is this. Yes. So 1 is for clerical, 2 is for custodian, 3 is for manager. And when said for clerical and manager, I think, right, ma'am?
Yes, ma'am.
Fine. So I'll again go to this analyze, compare means in one way and go. Click on contrast. Here in the coefficient, what you need to do for whatever 2 categories you want to find the significant or want to check the significant difference, you need to give some number to that. So here, suppose I'm giving 1 and adding it. So this is the first category, clerical. Second category, I want to keep absent. So I need to give 0 to it. And for the third category, I need to use the same number with the minus sign. That means it is an indication to SPSS that it has to compare first and third category, and second category will not be considered here for the t-test. Is it clear? Any number you can supply, but you need to keep in mind, if suppose you're giving any number here, suppose I'm giving 15. So I need to use minus 15 in case of whatever next category I want to compare, right?
Yes,
Clear,
ma'am.
everyone? Now click on continue and then OK. So you can find contrast test table is coming, which is containing t-test, visible. I hope it is visible, friends.
Yes, ma'am, it is visible.
Yes, ma'am.
So now you can see here, it is indicating variance was unequal in our case. So we'll go to the next last row here and you can check here. The significant value is 0.000, which is less than 0.05. So what comment you will do? You will say this thing that significant differences existing in the mean salary of the clerical and the managerialist. Is it okay? T-test is clear here?
Yes.
Yes, ma'am.
Fine. Now, this is about one-way ANOVA. I think one of you have asked about performing a non-parametric test, right? So for that, you need to go to the analyze, go to the non-parametric tests, and then go to the legacy dialog box and select K independent samples. Done.
Yes,
Clear,
ma'am.
everyone?
Yes, ma'am.
Just a minute. Then you can find this is for the critical values test. Actually, this dummy. I need to check one more time. Analyze non-parametric test. Independent sample. Suppose I'm going. Yeah, this is the correct way. Again, I'm showing you. Analyze non-parametric test and the independent samples. Done.
Ma'am, please repeat.
Okay. Analyze non-parametric test and the independent samples. Done.
Okay, ma'am. Thank you.
Now go to the fields. Here all the fields are listed. Suppose I want to check current salary. Shift to the test field. Gender, I'll shift here. Done. Fine, everyone.
Yes, ma'am.
Yes,
Then
ma'am.
go to the settings. In the settings, if you will not pass anything according to the data only, it will select which test is appropriate. But if you wish to select, you can click on customize test and select as if you want to perform man-Whitney, as we are having the gender variables, we are having only two groups, male and female. So in that case, man-Whitney test is applicable. But if you will take job category, so you can select this critical values test. Is it okay? And then you can run this. Clear?
Yes, ma'am.
Visible, I hope, right, ma'am?
Yes, ma'am.
Yes, ma'am.
Then you can double click on this. So the main table will come for you. Fine. Here you can report, you will get this man-Whitney test value and then P value. So this you can report. Fine.
Ma'am, what did you double click on? Could you say?
On the table. On this table. Double click on this. Done?
Yes, ma'am.
I hope it is clear.
Yes, ma'am.
Yes, ma'am.
Fine. Similarly, you will go to the analyze, again non-parametric, independent samples, and in the fields, this time rather than taking gender, you can take the employment category, right? And then settings, in customize, deselect this and select this. So this is for the critical values test. Done. Clear?
Yes, ma'am.
Fine. So friends, this way, I think today I tried to explain you one-way ANOVA and paired sample status. So I'm taking little liberty today as I'm not feeling much well. So I'm just concluding the session and I'll take your questions, right? So I'll conclude the session. I'll say today I'll explain you about the paired sample status. You understood that when to apply paired sample status when there is a dependency in your sample, right? Means for the same sample you are collecting data twice. That way you are using paired sample status, right? So we will be having only one sample and one variable. For the same variable, you will collect data twice for the same sample. Time period will be little different, right? So that is a paired sample status. Only two assumptions you need to test. That is for the normality and for the outlier kind of thing. And that whatever those two assumptions you are these two assumptions you are checking, you need to only see these assumptions will be checked for the difference. Means not for the actual variable, for the difference you are checking these assumptions, right? And I think performing is very easy, and that way you can make your conclusion of accepting or rejecting the null hypothesis. Afterwards, I discussed one-way ANOVA. I said one-way ANOVA is again a kind of parametric test, which is an extension of independent sample status. Because in case of independent sample status, you can only compare two groups. But what if you are having more than two groups? If you wish to compare them, you can use one-way ANOVA, right? So one-way ANOVA can compare all the groups simultaneously. So if in any of the group mean is not equal, it will say significant differences existing, but it will not check further in which pair the significant difference is coming, right? So using the various means after checking the various assumptions like normality, outlier, and the homogeneity of variances, you can conclude your ANOVA. If ANOVA results are saying that you are rejecting the null hypothesis of ANOVA, in that case, you will go for the multiple comparisons, that is post-hoc test. So I showed you there are two families of post-hoc tests, one for the equal variances and one for the unequal variances. So in case of unequal variances, I've told you which two tests you can generally use. In case of equal variances, I think that I haven't said because our data was not telling that equal variances existing. But if suppose for your research, equal variance comes, in that case, you need to select TUKEY, 2K. 2K, sometimes it is known as the K. Some people are saying it as 2K. I'll show you just a minute. I'll close this. I'll show you. Yeah. So this is 2K. This is you need to select, right? If equal variance is there. Clear, everyone?
Yes, ma'am.
Fine. So that way, these assumptions you can check. After checking your assumptions, you need to comment. Means you need to make up multiple comparisons and you need to then comment whether the significant difference is existing in the pairs or not. So that way, this is known as one-way ANOVA. So I think, friends, this is all from my side for the day. Now I am happy to take your queries. If you are having any, please ask. I think I am asking you, please, if you are having any queries, you please ask. No queries? Friends, say something.
No, ma'am. No queries from my side.
No, ma'am.
Thank you, Radhika ma'am. Thank you, ma'am. Fine. So if no queries, so Can we end up our today's session?
Yes, ma'am.
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Yes.
Ma'am, one thing, ma'am. Ma'am,
Yes.
yesterday's YouTube link of not full video is there, ma'am. Only half an hour it was there. If you want to recheck anything.
I think, ma'am, RFI team can give you the answer better for this. Yeah, I think as Yogi sir is saying, you please share your mail ID. Sir will provide you on your mail ID the full recording.
Okay, ma'am. Okay, ma'am. Thank you, ma'am.
Yeah.
Ma'am, take care of your health, ma'am.
Yeah, actually today I'm not.
Yeah,
I'm
yes, ma'am.
feeling,
Yes, ma'am.
I'm feeling.
Yes.
I'm feeling like I'm just puking. I don't know what happened today. I haven't had something. I don't know. I'm not.
Take
I'm
care,
not.
ma'am. Take care.
Yes.
Take care.
Thank you. So I think this is all from my side, friends. We are meeting tomorrow and we'll discuss cohesion and regression. So Yogi sir, I think I am done for the day. Thank you so much, everyone. We are meeting tomorrow again for the second last session.
Okay, ma'am. Thank you. Take
Yeah.
care.
Thank you, ma'am.
Thank you, ma'am.
Thank you, everyone.
Thank you.